Welcome to Introduction. Here we are trying to understand the Linux and SSH for DevOps. These are the agendas. We have Introduction, why DevOps needs Linux, Ubuntu and CentOS overview, SSH protocol essentials, why SSH is vital, and of course we are going to make a conclusion. Start with introduction. Today we are living in a world that is fast-paced, and that means also the process of developing the software is much faster. As a result, DevOps has emerged as one of the concepts because we say there's nothing but it's just a methodology that is being used by companies so that they can bridge the gap between the development and the operation teams. DevOps, as we know, is nothing but just a combination of development and operation. It has a set of practices, principles, and tools, and all of them are usually aimed at automating the software delivery process. The main goal of organization is always to deliver high-quality software, deliver the software much faster, be more reliable, be more efficient, and also be able to reduce the risk that are associated with delivering a software to the final customer. This is just an example of a DevOps pipeline. This is a very important pipeline, especially when we are doing or talking about the software delivery automation. As we saw in the introduction to DevOps concept, this software is usually integration of many tools that are put together. And the aim of the pipeline is to automate the processes that are involved in building of a software. In this case, we can see different kind of tools. And these are all tools. Some of them we are going to cover them in the course. Some of them are just alternative to the other tools that we are going to use. For instance, if you look at it, you can see that we have two major environments. We have the dev and we have the operation. In each part of this pipeline, you can say that we have different kind of tools. Some of these tools, you might not be familiar with them, but as we continue, you are going to be very conversant with them. Why DevOps matters? Again, this is back to the concept that we covered. We say that this is the era in which continuous integration and continuous delivery, which is commonly known as CI/CD pipeline, is a very famous concept. And DevOps is always important because it ensures that the process of delivering the software, not just building and delivering, but also the whole process of deploying the software, most of it is automated. And when we automate things, what happens is that things move faster. When we are able to deliver the software faster to the market, we are able to satisfy the customer. And this is what we are talking about when we say that through DevOps, we are able to be more efficient. We are able to be more responsive, of course, to the changing demands of the market and also what the customers are requesting. DevOps, of course, promote collaboration and communication, and this one we saw are the main concept of DevOps. Before DevOps came into the picture, we used to have traditional kind of structure in the companies, which means each department was all by itself. We can look at a department like the operation. Mostly is involved in the process of operating the application. We look at another department like development. It was all by itself, and mostly was focused on coding and, of course, developing the features of the software. Those two departments were separate, which means there were so many barriers between the two of them. There was no communication. There was no collaboration. And of course, DevOps came in and is able to solve that issue. We look at DevOps ability to empower the organization in a way that organization is able to release the new features much faster and quicker, and is able to release them frequently, because the aim of DevOps is to automate most of the processes that are manual. And again, we go back to the concept in which we said we do not automate everything. We are mostly concerned about automating the tasks that are repetitive. And again, of course, automation, which is one of the key concepts of DevOps. And the reason we are automating is to reduce the human errors, enhance consistency, and allow team to focus on innovation rather than just doing repetitive tasks. Here we are looking at the role of the operating system and also SSH. These two go together because most of the servers that we are managing today, they are not servers that are within the area that you are. We are going to be working with servers that are on AWS cloud. They are very far. Some of them are in the cloud, some are very far from where you are. So the concept of SSH, which is going to be helping us to be able to connect with these servers remotely, is going to become very vital. As you can see, at the heart of DevOps ecosystem, we have the operating system. We cannot do anything without the operating system. Specifically, the operating system that we are very interested in is what we call Linux. And Linux is going to be the foundation of many DevOps practices that we are going to see in this course. There are many benefits that come with the Linux operating system. One is that it's an open source, it's free. It's also easy to scale, it's very flexible. When we talk about flexibility, here we are looking at the different kind of Linux distros, or what we call distributes. There are several of them, as we are going to see, that give you the flexible as a company, because you can use any of them. Here we are also able to see that Linux provides a robust environment for hosting the tools and services that are required, specifically for the automation. One way, of course, we automate in DevOps is continuous integration, continuous development, or continuous delivery. The famous CI/CD pipeline. We need tools to be able to do that. The beauty of it is that Linux do support all those tools. Self-containerization is another concept you are going to see. We do have orchestration, another concept to see down the line, and all those are very important concepts in DevOps. This is something you can do. This is a homework for yourself, and this homework is more focused on Linux distribution. Some people call them distribution. They can also be called distros. They can also be called flavors. So focus on this homework. You need to go research and compile a list of at least 5 well-known Linux distribution or distros. After being able to compile the list, you need to go to each distribution, provide a brief overview, its history, primarily the use cases, and also some of the notable features. You also need to compare and contrast the distribution because they are not the same. Highlight the key differences that make each of those distros unique from each other. Specifically, your focus should be on Ubuntu Linux, CentOS Linux, Debian Linux, and of course, Amazon Linux. Now here we are looking at the role of operating system. We continue with the same thing. And now we are done with the distros, distributed operating system. Now we are focusing on SSH. SSH stands for Secure Shell. is secure communication, because they help us to have a secure communication that is very important, especially when we are managing, accessing, and deploying application on remote servers. So here, the focus should be on the remote servers. These are servers that are not where you are. They might be in the cloud infrastructure, or they might be virtualized servers. To ensure secure encrypted connection for remote administration. So when you are trying to access the server that is remote, there are some sensitive information that you need to put in. You need to put the IP address, you need to put your password. Password is not always recommended, but you can put something like SSH keygen. You do need to put your username. All that information is sensitive. So we need to encrypt the information so that we can make sure that our systems are secure. In this presentation, we'll continue, of course, to go deep into the pivotal roles of Linux operating system, and we'll continue to look at SSH, specifically why it is important in DevOps landscape. As you know, it's very difficult today to have access to the physical servers where you are. You can do that, but most of the servers in the companies are always going to be in somewhere, mostly in the private cloud, or also in the public cloud, where they have created their own private cloud. So you need to access these servers remotely so that you can do automation, patch management, and you need to do so securely. So SSH is going to come in and will help us to do that. Now here we are looking at the common Linux distribution in DevOps. We have Ubuntu, we have CentOS. Ubuntu is usually very famous. I also like it. It's very user-friendly, has a very nice interface. Usually when you type your commands on Linux, it does support you by suggesting maybe you're missing something, maybe you need to install something, and that's not something you find a lot in CentOS. Ubuntu also is able to offer long-term and short-term versions. For instance, the long-term are usually, they come every 2 years. If you have noted, the concept of Ubuntu is usually that we have Ubuntu 18, 20, 22, 24. Between each 2 years, let's say between 20 and 22, we do have 21, but 21 is not a long-term support. It's usually a short-term support. So what does long-term support means? It means that every version that is long-term support, it gets 5 years of support from the Ubuntu's developers. Also, Ubuntu is very compatible with a wide range of DevOps tools, and this is going to be important, especially for automation framework. Let's look at CentOS. It's very reliable, very stable. It's very important and usually ideal for building enterprise-grade infrastructure and hosting applications. It is used especially in web server deployment, and also is very important when we are running containers. Again, those are concepts we'll see later on. Unlike Ubuntu, CentOS usually release their long-term support after every 10 years. That's very good, because it means you don't have to be worried too much. In 10 years, they guarantee support of their developers. This is just a comparison between CentOS and Ubuntu. You're going to realize that all these servers, operating system, they come with their own package command or package management for commands. They are not the same. For Ubuntu, it's usually RPM and yum. This is why we say yum install. For Ubuntu, it's usually going to be apt-get, but currently we are using apt, so don't bother about apt-get. It's quite old-fashioned. Variant, of course, Centos is more related to Red Hat Enterprise, but Ubuntu is more based on Debian, which means even though they are both Linux in terms of operating system, their OS name, which is now what we are seeing here, Ubuntu and CentOS, they have some variation. Especially you are going to see this when you do the project that is comparing the CentOS and Ubuntu, you're going to see that some commands work on both. Especially when it comes to package management, Ubuntu you must use apt, CentOS you must use yum. Here we are looking at the percentages of the website that are using CentOS compared to Ubuntu. As you can see, Ubuntu is winning, 34.8%. CentOS, 20.4%, is winning by almost 14.4%. That's quite a huge number. Release cycle, CentOS 10 years, long period. Ubuntu 5 years, short period. In terms of security, CentOS is considered to be more secure out of the box. Ubuntu is considered to be less secure out of the box compared to CentOS. These are other Linux, of course, these are other operating systems that are also famous. We have Debian, we have Fedora, we have Amazon Linux too. This Amazon Linux 2 is becoming very famous and is mostly for Amazon. So we are going to use it a lot, especially in this course. But one thing I can say, even though it's still a Linux operating system, but they have a different OS name, which is the Amazon Linux. These are just logos. As you can see, common Linux distros distribution in DevOps. Fedora is there, Debian, and here how the Amazon Linux look like. It's just a logo with some servers. Now we focus fully on the Linux operating system. I want you to understand that just because I'm focusing on Linux, Linux is not the only operating system that we have. We do have other operating systems such as Windows. Usually some people like to call it NT, new technology. We do have Mac OS, we do have iOS, we do have Android, and many others. But we are looking at Linux operating system because it has many benefits. It's an open source, which means a lot of people, the community is huge. Let's look at the open source foundation. You can see that Linux is open source, which means the source code is freely available to anyone. And you can be able to view, modify, and distribute it. And this is why we have different kinds of distribute that are based on Linux. Let's look at DevOps pervasiveness. Linux, of course, is widely adopted in the DevOps world because it's very flexible. It's also easy to scale and is very compatible with many tools. What about historical significance? Linux was created in 1991 by Linus Torvalds. Quite interesting. And has continued to grow and now has a very huge community that is under Linux. Is community driven, and this community is global, which means there is collaboration of many developers, volunteers, and organizations that are working tirelessly to keep improving the Linux operating system. Foundation for innovation. We are able to see that Linux serves as the foundation of various DevOps practices. We know automation is one of them. And the question is how? How does it do this? The answer is very simple. It is able to support most of the tools that we are going to need as DevOps while automating the infrastructure or automating the repetitive task. Most of those tools are usually very compatible with the Linux operating system. It's also very good in containerization. It's a concept we are going to see as we continue in the course. It's also very compatible with orchestration tools like Kubernetes. So when building our CI/CD pipeline, which is the heartbeat of DevOps, it means that that's your main job as a DevOps engineer, to make sure that you're able to create robust and scalable CI/CD infrastructure. Making Linux your choice of operating system is a good one, because it means it's going to be compatible with most of the tools that we are going to use for automating purposes. Let's continue. It is difficult to understand the operating system without understanding its components. So we have different components. So when you see the operating system, it's not just one thing. As you can see, we have 1, 2, 3, 4, 5, 6. No, 5. Actually, it's 5. We have the kernel, we have the shell, we have the file system, we have utilities, and we have libraries. The way I organize this is from the priority, which one is most important inside of the operating system. Of course, the kernel is very important. Let's see what they do. Going to start with the kernel. The kernel is nothing but it's just a resource management. It is one of the key components of the operating system of Linux. And the work is just to manage hardware resources such as CPU, memory, and also the input and output devices. So it's able to allocate resources to various processes and ensure that all your application and processes are running effectively. In DevOps, the kernel is going to be very crucial to us because it's going to be managing the resources that we need to run applications, containers, and even the virtual machines, which we are going to create when we get to the concept of virtualization. And that's very important, especially when we focus on what we call optimal performance and resource utilization, and also the cost that is associated with running our systems. We now focus on the second component, which is the shell. The shell is, we have a usage of it, which is command line interface, or what we commonly call CLI. The shell is very important because this is how you interact with your server. The work of it is you type commands on it, then it interprets the command, and you enter. It's also where we are going to be running the script. Why do we need script? We need script because we are going to use script to automate the tasks that are repetitive, such as configuration of the server, installation of the packages, automation of the backup, backing up our database. Those are all things that we are going to use automation for. Then Linux is highly based on what we call the file system. We have the root directory. Then, of course, it branches like a tree. I have a recording on file system of Linux. And we are going to cover exactly how those files and folders branch from each other. The file system is important because this, especially for data storage and organization. The file system provides a structure and mechanism of storing and organizing your files and directories on storage, such as hard drive and solid-state drives. As DevOps engineers, you need to be very crucial and you need to understand exactly how the Linux file system and directories work. That knowledge is important because that's what you are going to be using to be able to manage the configuration files, be able to know where your logs for the systems are, be able to apply the application code, and also be able to know exactly which data are important for your system and how to back those data. You also need to ensure that the data is stored effectively, efficiently, and securely, and is able to be accessed by the application and also the script that you are going to be using for the automation purposes. We come to the fourth component of the operating system. In this case, it's nothing but the utilities. Utilities are very important, especially to system administration and maintenance. Utilities in Linux, of course, they are very specialized programs, or they are just commands that we perform that are very important in performing a specific task. And they vary. They all perform a wide range of activities, or what we call tasks. Some are into file manipulation, some are into network, some are into system monitoring, etc. So we as DevOps, we are going to be using these utilities a lot, especially to gather system information so that we can see how our systems are operating. We are also going to be using them, of course, for troubleshooting and also to automate routine administrative tasks that we do on a daily basis. Example, we have a very important command. We have the grep, which we use for searching things in the text. It's like for search. You want to search the word device in this PowerPoint slide, you can use grep. But again, that's not what I want you to focus on. I just want you to understand that this is a utility we are going to use, especially if we are searching a certain text, word, or number inside a huge file. Have libraries. What are libraries? Software development and compatibilities. Libraries in Linux are nothing but just a collection of pre-compiled code. And these pre-compiled code are important because that's what applications are going to be using. Most of these pre-compiled code are reusable. So they save a lot of time because you don't have to be writing them over and over. They're repetitive tasks. It's better for them to be reusable. We use these libraries, especially when developing custom automation scripts. We need script. We are going to talk about script all the time because it's what we need to automate the repetitive tasks that we are going to be working or doing every day in our department. Libraries, they help us, of course, with the code efficiency, maintainability, and compatibility across different Linux distributions. We are going to write many scripts in this course. We're going to have different types of script from configuration of the system, installation of packages, backing up of our system, installation of packages, opening of the port, management of the firewall rules, and all that. So you're going to have enough practice on scripts. Now we look at some of the important resources which we saw the kernel is usually manages. We have the CPU, which is the central processing unit. We have the RAM, which is a random access memory. And we have the storage device, which is very fundamental, especially in long-term storage of files and folders. What is the work of CPU? The CPU serves as the brain of your server or computer. It executes instruction, perform calculation, and process information that is coming to your application that is hosted inside the operating system or server by itself. RAM, of course, provides the fast temporary storage for data and instruction that can actively be used to run a program. It is also important because it helps your server or your system to be able to create or allow a quick access to frequently accessed data. Finally, we have storage, and storage is either going to be HDD or SSD. And you can do this when you are creating your servers. We are going to see this on AWS. When we create our servers, we are going to have the privilege, of course, to decide what kind of storage that we want. Of course, SSD is always better. Solid state drive is much quieter, very quiet. And we need the storage for long-term storage of files, data, etc. Now let's see how Linux interact with these resources. Linux interact with this component, of course, through the kernel. We saw that the kernel is the one that manages the hardware resources. And the work of it is to manage resource allocation. How much should the application get? How much CPU, how much RAM? And also be able to schedule tasks to the CPU where they are supposed to be processed. They also handle the data and read and write operations that happen between the RAM and the storage device. This interaction, of course, is very important because this is how the application that you are running inside of the server is able to have access to efficient and enough resources to allow the application to have what we call optimal performance. And the optimal performance is very important in making sure that the customers are satisfied. Let's look at the compatibility. Why DevOps need Linux? Because we use so many tools, especially for automation purposes, it's very important to have an operating system that is very compatible, is open source, and can use different languages. And of course, Linux qualify for all that. So if we know it to qualify for that, then it will become a very important operating system for us. All the systems, all the applications, all the containers we are going to be working with, they are going to be running inside the operating system or inside the server that is built on this operating system called Linux. The best thing about Linux is that because of the kernel, it has a very effective kernel. It is also very efficient when it comes to resource management. And this is going to help us, especially we as DevOps, to be able to maximize the utilization of CPU, RAM, and other system resources. And that effective and efficient usage of the resources also help us to cut the cost because we are not wasting any resources. CLI is very important. This is how we run the script. This is how we automate tasks. Automation of tasks, as we have seen in DevOps, is very vital. If you do not automate the task, we are going to have what we call bottlenecks. Bottlenecks are going to affect the speed at which we can deliver the software. When the speed is slow, we are not able to adapt to the market. If we are not able to adapt to the market, we are not able to help the final customer. So we need the command line interface that is very effective. And of course, Linux gives us that option. Security and stability. Specifically Centos, which is a distro of Linux. They are renowned for their security features and their stability. They have, of course, robust access control. Regular security updates are always done by the developers. And they have a vast community of contributors and volunteers, and that continue to improve the Linux operating system and also continue to make the Linux operating system secure, reliable, and a very favorable choice for DevOps. In this slide, we are going to focus on the two operating systems, not two operating systems, but two distribute or distros of Linux that are very famous today. Both of them combined take about 60% of the market share. I'm going to start with Ubuntu, which is usually my favorite and also is a favorite for many people. And some of the strength, of course, of Ubuntu is that it is very user-friendly. It has, of course, extensive package management repository. It's usually ideal for many tasks that we are going to be executing as DevOps. It's also very important when it comes to web hosting and also cloud deployment. Let's look at Centos. It's more of Red Hat based. It's a Red Hat based. And also it offers enterprise grade stability. It's very secure, very stable. New release every 10 years. It's always preferred, of course, for building robust and secure infrastructure, especially in the corporate and the data center settings where information is very sensitive and the data need to be built upon a secure system. So Centos become a very good choice in such environment. Ubuntu will continue. Let's look at the role in the DevOps ecosystem. And you are going to see that Ubuntu Server is a popular choice, of course, for DevOps practitioner, cloud practitioner. And this is because it is very easy to use. In fact, when you go on the CLI of Ubuntu and you type something like Docker images, just looking at the images of Docker, and Docker is not installed, Ubuntu is going to give you suggestion on how to install Docker. At this point, don't worry about Docker if you are not familiar with it. It's a concept we'll cover in this course, and videos will be available for you to go through the concept of Docker in deeper. It serves as a solid foundation for people that have interest in web applications, running containers, which is becoming a very popular concept, and implementing automation workflow. Centos remain very reliable. Long-term support make it very reliable choice for DevOps team that want to focus on stability and security. It is commonly used and preferred, especially when it comes to creating virtual environment. Of course, when you are running critical services and you want to ensure that you have consistency in performance and also in security-wise, especially in your CI/CD infrastructure and all those infrastructure that are vital to DevOps, then you can go with Centos as a choice. Now we enter into the SSH protocol. I want to remind you that SSH protocol, the port it uses is port 2222. SSH stands for Secure Shell. SSH is widely used as a network protocol. Why is it used a lot? Yes, it's used a lot because it's designed in a way that is able to provide you secure, encrypted communication over untrusted network or internet. And this is very important because it's able to ensure data integrity and confidentiality. Let's look at its role in managing remote servers and devices. We are going to see that SSH continue to play a pivotal role, and this pivotal role is actually in managing remote servers. It's also in network devices and other systems security. The word here you should be understanding clearly is secure, because when you are actually in the process of accessing the server remotely, you are going to be given information that is crucial. Such information include IP address, username. So we want that information to be encrypted. Otherwise, somebody can eavesdrop and be able to get information, access your server, and cause damage to the company. It will allow administrators and DevOps professionals to establish secure, authenticated connection to remote machines over potentially insecure network like the internet. Because if you are going to be accessing your server remotely, of course you are doing it through the internet. Internet is never secure. So we have to find a protocol that is secure and is going to make sure that all the connections that are connecting to our secure environment, they are authenticated. Otherwise, we can face a huge danger. Let's look at encrypted communication. What does this mean? SSH encrypt the data, make data the secure. Even if you access the data, you really can't know what it is in. This is important in making sure that we are preventing what we call the man-in-the-middle attack, making it a crucial tool for transmitting sensitive data and also being able to type your commands, being able to deploy your applications. It is to make sure that that process is secure. Remote share access. SSH provides a secure command line interface, what we commonly call CLI, for remote system, and we can be able to execute commands, manage the files, deploy applications remotely, and also be able to run our scripts so that we can automate repetitive tasks that are in the departments or in our workplace and make sure that we deliver the software much faster. Through the SSH, we are also able to do what we call secure file transfer. Some of these files are sensitive. They contain information, data that is sensitive. So we need to have a secure way that we can be able to transfer them, probably from one server to the other. And we can do what we call SCP, Secure Copy Protocol. You can also use SFTP, which is Secure File Transfer Protocol. The best thing you should know here is that both systems or both protocols, whether it's SCP, SFTP, they both utilize what we call SSH. We also have port forwarding. SSH allows for secure port forwarding, enabling users, of course, to tunnel network traffic. We continue with the use cases. Here we are looking at SSH use cases. SSH is indispensable. Very, very tough name. In the DevOps world for managing and configuring remote servers. It's just saying it's irreplaceable. Yeah, it's very important. This SSH protocol, vital, because it helps us to automate deployment processes, manage the servers remotely, be able to manipulate and configure the system, be able to monitor our remote system, be able to automate tasks. So it's a very important protocol. This one is almost irreplaceable. It is also widely used for securely accessing the cloud instances. When we talk about instances at this stage, just consider them to be servers. We are talking about virtualized servers or servers that are in the cloud. Managing network devices, connecting to what we call Internet of Things, which is becoming a very famous concept, and also other devices securely. What is the best security practices when it comes to SSH? To be able to maximize security when you are using SSH, it is essential to be able to implement the best practices. What are some of those best practices? Prevent the employees from logging using the password-based authentication process. Because, hey, you never know where somebody can store the password, and somebody can get access to the password, log into the system, and be able to cause damage to the company's system. So the first thing is that you need to disable the password-based authentication. That means that when somebody or when a person or when a DevOps is trying to access the server remotely, when they enter, of course, the SSH command, they say yes, of course. They are usually tempted to enter the password. That's not the best SSH practice because we are risking and making our system vulnerable. You should be able to monitor the SSH logs and see whether there is any suspicious activity you can be able to trace. Now, in this course, we're going to deal with a lot of operating system. In this case, we are dealing with Amazon Linux. This is a project you are going to execute. And in this project, all you need to do, you must create a AWS account. When you create an AWS account, you are going to log in and you are going to follow these steps to be able to launch your first server. In the next video, I'm going to cover exactly how to launch a server following these steps on AWS, how to SSH, and how to execute a few commands that are famous to DevOps. There are many steps, so you're going to continue like this. All these steps are important, but I'm going to tell you that because we are DevOps, we don't do things manually. However, at this stage, it's too early for you to be able to automate. So as we continue with the course, we are going to come up with different tools. Again, those tools are compatible with the Linux operating system. We are going to use scripts. We are going to use configuration files or configuration files, which we are going to use together with some tools to automate the whole process of creating the Linux instance or Linux operating system on AWS. We don't have to follow all these steps. They are like, that's almost 6, another 5, another 4. That's so many steps. Imagine you have to create 10 servers for different teams in your company. And each time you have to follow all these steps. Of course, you're a human being. You are going to forget some things. And this is why we are going to focus on automating, because automating is very easy. It's just a simple thing of modifying the configuration files and then running the files. And that's going to, of course, to give us consistency. All servers that we create through automation are going to be the same. That's very important because we don't have to have a lot of troubleshooting because this department has this kind of environment, this one has this kind of environment. Automation is very vital because it will help us to standardize and also have consistency when it comes to creating our infrastructure. So that's all I have for today. So look forward to the next video where we are going to follow those steps, manually create a server on AWS,